Hey y'all, Miss Harper here for parallel and perpendicular lines. Alright, this stuff is pretty groovy, just a little extension of some of the linear functions we've been working on. So let's go ahead and graph these two lines. If you want to challenge yourself, you're welcome to pause the note video and try to graph these lines on your own. So if you want to do that, pause now. If you're going to stay on with me, we will talk through this. Alright, so graphing these two linear functions, remember we start at our y-intercept. And then from here, my slope is 3. Remember, if it's a whole number, I rise over run, it goes over 1. So I can't go up 3, but I'm going to have to go down 3 and to the left. 2, 3, 1, 2, 3. Alright, and here is the first line for y equals 3x plus 4. Alright, I'll do the second one here. Now the only difference is my y-intercept's down here at -4. Alright, but I have the same slope of up 3 over 1. So from here I'm going to go up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. And now we have these two little cuties. Let's go ahead and just talk about this line. Okay. So it says to graph each set of lines, and what do you notice? Well, what do we notice about these two things? They do not touch, they do not intersect. Do we see anything else? So here I'm going to say lines don't intersect. Alright, and one other thing that I notice is in their equations. They have the same slope. If you notice, both of their slopes were 3. And one last thing is we call these parallel lines. Kind of like railroad tracks, those two things will never cross. Alright, let's hop over here to B. And first thing, what is our y-intercept? If it's missing, it is 0 for both of these. Alright, so let's go ahead and graph these. I'm going to graph the first one starting at 2. And again, for this one, my slope is going to be 2 over 1. So I'm going to go up 2 over 1, up 2 over 1. And then I'm going to follow that pattern backwards. And there's my first line. Here comes my second line. My y-intercept again is at 0, but this time my slope is -1/2. That means I'm going to go down 1 and over 2, down 1 over 2. I'm going to do the opposite, up and over, up and over. Nice, pretty straight line. And let's talk about these. Oh, what happened? Why did it do that? Sorry about that extra line in there. Don't like that. Anyways, these things cross at what you see as a perfect X. So we call that a 90-degree angle, which is fabulous. All right, so let's take some notes down here. What do we notice? Well, I notice that they intersect at a 90-degree angle. These are what we call perpendicular lines. Kind of a big word, perpendicular, perpendicular. All right, sometimes I'll abbreviate that and call it perp. Okay, so there is that stuff. Other thing to notice about their slope. Let's just make note of what their slope was. One of the slopes was 2, and the other slope was -1/2. You might notice a relationship between those two things. So we're going to talk about that down here. Words and things to know. Alright, so parallel lines. Parallel lines, they are lines that never, that was weird, never intersect. Alright, and another thing, they are lines with same slope. Alright, remember we call slope M. Alright, so some examples. Maybe you could come up with some examples of your own. So for example, maybe I have y equals 5x plus 1, and my other line is y equals 5x minus 7. Okay? Or whatever crazy number you want to put in there. But most important thing is that they have the same slope. Okay, and some other examples, and let's try one with a fraction. Maybe I have one that is y equals 3/4 x plus 2. And so my parallel line would again have the same slope, and same slope, just different y-intercepts. And those things would be parallel because they have the same slope. We love it. All right, perpendicular lines are a little different. Okay, so they are lines that intersect at a 90-degree angle. And the relationship with their slopes, get ready. Slopes are opposite. Sorry, I don't know why I did that. Opposite reciprocals. Okay, so I'm going to make some little side notes. So opposite tells us to change the sign from positive to negative. All right, so if you look back at these, notice that one has to be going in the positive direction, and for the other one to intersect at a 90-degree angle, he has to be going in the negative direction. So one is always positive and one is always going to be negative. The reciprocal tells us to flip the fraction. So you're going to hear me say that at least a million times. Opposite, change the sign. Reciprocal, flip the fraction. All right, so some examples of that. Maybe we have like y equals 3x plus 1, okay, in our slope. So think about 3 as our slope. All right, to make him the opposite reciprocal, opposite would tell me to change the sign. So now he's negative. And remember, anytime we have a whole number, 3, it's going to go over the number 1. So if I flipped this fraction around, it would become negative 1 over 3x. And it doesn't matter what y-intercept you give it. It could have any y-intercept. It could even have maybe the same y-intercept, and that would be their point of intersection. All right, let's try one more example. Maybe we have y equals negative 5 over 2x plus 1. All right, so what would our new perpendicular line be? All right, we got to change his slope. Opposite tells me to change the sign, so he's going to be positive. Reciprocal says to flip the fraction. Maybe it's that. Okay, so again, it all has to do with their slopes. Opposite reciprocals for perpendicular, or same slope for parallel. On to the next. Oh, actually, I wanted to make one more note. Oops. Oh no. Okay, so just wanted to make a quick point here. Let's say here's my x and y axis. All right, sometimes we have lines that just straight up intersect. All right, maybe we have something that looks like this. All right, these are not perpendicular. All right, because they don't cross at that perfect x. Remember, we need them to look like this, so that way they cross at a 90-degree angle. All right, so since those are just regular intersecting lines, they are not perpendicular. Okay, on to the next. Here we go, writing equations of parallel lines. So just like any of our functions, we just need a slope and a y-intercept. All right, so it says to write the equation of a line in slope-intercept form that is parallel to this line, and our new line is going to go through this point. So the only thing we care about with our original line is his slipitous slope. All right. Since we're parallel lines, write the information you need to write the equation of the new line. So my new slope is still going to be 1/2 because it's parallel, so it's the same. And my x1, y1 is the point that they gave us, 3, 1. All right, now I have a point and I have a slope. What are we going to use? Point slope formula. Yeah, we are. So write kind of tiny. I know y'all don't have a ton of space. All right, so I'm going to have y minus y1 equals m times x minus x1. All right, and that's just our usual from here. We're going to distribute on the right, minus 3/2. And then I'm going to add 1 over here. And I know you're not doing this, which is fine. I'm just going to tell you what this becomes. Negative 1/2. Alright, so the slope equation of the parallel line, my new line, is going to be 1/2 x minus 1/2. And we can always put these two things in our calculator to check and see that in fact they are parallel, but for time's sake I'm going to skip that. But if you want to pause and go do that, I would love it. Alright, on to writing equations for perpendicular lines. Parallel is pretty easy. Again, same slope. This one gets a little different. So same thing, equation is here of the original line again. Oh, there's a typo on there too. Oh, this should be y equals negative 1/2 x plus 3. Alright, so the only thing I care about from the original line is his slope, and then I care about the point that they gave us. So since my original slope was negative 1/2, I need to create a new slope. Opposite tells me to change the sign. So now it's positive, and reciprocal tells me to flip the fraction. This is going to become positive 2 over 1, which just equals 2. Sorry, the announcements have started. Hopefully you can still hear me, except they yell so loud. Alright, so our new point, it needs to go through 1, 4. So this is my x1 and my y1. Alright, and so we go with our same thing. Y minus y1 equals m times x minus x1. Y minus 4 equals 2 times x minus 1. Y minus 4 equals 2x minus 2 after we distribute. Add that 4 over. And we end up with y equals 2x plus 2. Alright, so y equals 2x plus 2. Alright, and then again, plug these in your calculator. Make sure that they are perpendicular lines. On to the back. Graphing parallel lines. They want you, I don't really love the way that they did their steps here. I would actually think it's better to find the slope and then write the equation. Alright, so our slope, if it's parallel, remember we need to rise over run. So to get from a left point to a right point, I have to go down 2 over 1. So my rise over 1 is down 2 over 1, which is negative 2. Alright, and it wants it to go through the point 0, negative 2. Well, what's special about this line? That is our y-intercept. Okay, so I'm going to go ahead and skip to write my equation. I know that my slope is negative 2, and I know my y-intercept is also at negative 2. Okay, sorry about the interruptions with the announcements. They are so loud. If anybody knows Gwen, tell her to stop screaming. Anyways, I'm going to go ahead and graph my new line now. My y-intercept is down here at negative 2. And I have a slope of negative 2, so down 2 over 1. Now I'm going to go the opposite, up 2 over, up 2 over. Alright, and now my lines are parallel. Notice how they are not touching each other. Okay, so that's great. Alright, now for perpendicular lines, same thing, different slope. Alright, so graph the equation of the line that is perpendicular to the line below and goes through this point. Then write the equation. Okay, so first let's figure out what the slope is of our given line. The given line is going to be from a left point to a right point. I have to go up 3 over 1. Up 3 over 1 is just 3. Alright, step 2, determine the slope of the perpendicular line. So if my slope was 3, my new slope needs to be opposite. Change the sign, and reciprocal, flip your fraction, negative 1 over 3. Alright, remember it's not opposite. A lot of students want to call that negative 3. That's just opposite. Reciprocal, you have to flip that fraction. Okay, start the given point. So I'm going to go ahead. Again, this is a special point because it's our y-intercept. So I'm going to go ahead and write my equation first. My slope is negative 1/3 x, and my y-intercept is at negative 2. So I'm down here at negative 2, and my slope is down 1 over 3. Now I'm going to do the opposite, up 1 over 3. And here is my new perpendicular line. Alright, notice that these cross at a perfect x, and they make a 90-degree angle. That means that they are, in fact, perpendicular. How are graphing parallel and perpendicular lines different? For me, I would say parallel is easier because they have the same slope. Alright, perpendicular is trickier, or maybe we say harder, because slope has to change. Alright, so parallel is easy because we keep the slope, but perpendicular is a little trickier or harder because we have to change the slope. Alright, on this last one, I want you guys to actually practice through here on your own. I do want to go over, the only two I'm going to go over is number 2 and number 5. The rest y'all are going to figure out on your own, and then you're going to come show me your work so I can check it. Alright, so y'all are going to practice this. Parallel to this line goes through this point, find your equation. But I am going to go over the special cases with you, our Hoy and Vux. So this one is Hoy. So my recommendation for things like this is to make a sketch. Make a sketch. So fun fact, Hoy and Vux are perpendicular to each other. So let's say we made a little sketch. Okay, my line is y equals negative 2, so I go to my y-axis at negative 2, and it's a horizontal line. Alright, so this is my line, y equals negative 2. Alright, I know that my slope here is 0. So for this new line to be parallel, his slope also has to be 0. Alright, so let's say new line. I know that the slope is still going to be 0. But it also has to go through a special point, and the special point it has to go through is 3, negative 1, which is right here. Alright, for these things to be parallel, this also has to be a straight horizontal line, so that way they do not intersect. Alright, so again, special case, this purple line, we could say y equals, it has a slope of 0x, and it cuts through the y-axis at negative 1. Or we can just abbreviate it and call it y equals negative 1. Alright, then we switch gears and we go to perpendicular. Figure out your perpendicular equations, and then again, here's my special case. Again, make a sketch. I'm going to actually let you guys try to figure this one out, but I want to make one last note here and just say that Hoy, Vux are perpendicular. And it is helpful to make a sketch for special cases. Sorry, I was a little rushed here at the end. Class is starting. If you have any questions, come see me. But also, you're going to finish this half up, bring it to my desk so I can check them off, and then you can get your practice for the day. Good luck. Oh, and don't forget to like and subscribe. LOL.